Hello. So in this presentation, I will be talking about the three important aspects related with the time study, and these are how to determine the number of observations to be taken during the time study, so that we have the desired degree of the confidence level and the accuracy in the data measured. The another aspect about which we'll be talking is the performance rating, the methods which are used for performance rating, and lastly we'll also try to talk about the workers, the qualified worker and the average worker, and how do we identify the qualified and average workers. So we'll be starting with the determining the number of observations, determining the number of observations to be taken for time study. So as I said, there are different methods. There are three different methods. One is the customized tables developed by the firms. So this is like company specific. It considers the frequency of occurrence of the activity or the job. Then it also considers the cycle time of the job. These are the two important parameters which are used in determining the number of observations to be taken for conducting the time study. Okay, the another method is Mundell method. In Mundell method, a few random observations are taken in the beginning, say 5 or 10 number of observations are taken. Then what is the highest value h and the lowest value of those observations. Using these two, we determine the ratios, and those ratios are used to identify how many observations we should take for 95% confidence level, 10% accuracy, or 95% confidence level, 5% accuracy, or 10% accuracy. Third method is here a statistical method. So in statistical method, based on the requirement of the confidence level 95% or 10% accuracy, or like say the 2% accuracy, 5% accuracy, statistically the number of observations to be taken are identified. Okay, so for those many times, for those number of observations, the time study is conducted to arrive at the suitable representative value for which the time study has to be conducted. So now we will see these are the three different methods. So as far as the first method is, these are the three methods, like use of table, Mundell method, and statistical method. So in use of table, like these are the company specific. Okay, so the companies develop their own tables for the purpose of conducting the time study, which gives the idea of how many observations should be taken for the different types of the jobs based on their cycle time and the frequency of occurrence. So cycle time and the frequency of occurrence, these are the two important parameters which are considered in determining the number of observations to be taken. So like say this is one typical simplest table which shows depending upon the cycle time, it is up to say 0.1 minute cycle time, the 200 number of observations are taken, and up to 0.25 minutes of cycle time, 100 observations are taken. Then for up to 0.5 like say 0.5 minutes 60 observations, 0.75 40 observations, 1 minute 30 observations, 2 minutes 20, and like this. So longer is the duration of the cycle time, lesser will be the number of observations are required for conducting the time study to arrive at the more acceptable value of the time standard. Okay, this is the another one. Is earlier in the previous table we have talked just about this is one typical table which talked about just the cycle time related aspect. This is the another table. In this table the frequency of occurrence per year, like how many times the job is done per year, like say 1 to 100 times per year, or 100 to 10,000 times, or more than 10,000 times. So depending upon the frequency of occurrence of particular job, and then job cycle is the another parameter. So for very short cycle jobs, less than up to say 0.1 minute, it is 50 if it is occurring 1 to 100, and 60 if it is occurring 100 to 10,000, and 120 if it is occurring more than 10,000. So increasing the cycle time duration, if you see the number of observations to be taken for a given frequency per year, that will also be decreasing. Okay, so if the cycle time is say 8 minutes, the number of observations in case when it is happening in a range of 1 to 100 per year, then the number of observations to be taken is 6. If it is occurring it is 100 to 10,000, then it is 8, and it is more than 10,000, then it is 15. Likewise, if the cycle time is of 1 hour, then 2 observations, 3 observations, and 4 observations, 5 observations, depending upon the number of cycles per year a particular job is being repeated, or that is the kind of frequency of occurrence of the job. So these are the two typical customized tables which will indicate the number of observations need to be taken to arrive at more acceptable and a representative value of the time standard while conducting the time study. The Mundell method is the another method. In this method, there are 3 steps mainly. So in this method, first we take few readings of the work cycle. Say these may be 5 or 10. So 5 readings are taken when the 10 readings are taken if the cycle time is less or less than 2 minutes, and the 5 readings are taken if the cycle time is more than 2 minutes. Okay, so whenever readings are taken, in those readings, what is the value of H, highest value of the reading and the lowest value of reading. So using these H and L values for each set of, like say, the 10 readings or 5 readings as per the cycle time, we determine the value of ratio of H minus L divided by H plus L. So this ratio is used to determine the number of observations to be taken. Okay, so as I said, H is and L are respectively the highest and the lowest value of the reading in the set that we have obtained through the preliminary observations of 10 readings for less than 2 minute cycle time or 5 readings for more than 2 minute cycle time, and corresponding value of the ratio of H minus L divided by H plus L is used to determine the number of observations to be taken. So in the following slide there is a table which will show the number of observations for different values of H minus L divided by H plus L ratio. Okay, so that table shows the number of observations to be taken for the 5% accuracy and 95% confidence level, and if the precision desired or accuracy desired is 10% and then confidence level is 95%, then the values given in the table for the number of observations need to be multiplied by divided by 4. So for 10% precision and 95% confidence level, divide the number of observations given in the table by 4. Say for 5% accuracy and 95% confidence level, the data is coming say 12. Number of observations are coming 12. Okay, for a given value of h minus l divided by h plus l, and if we need the 10% accuracy and 5% confidence level, then this will be divided by 4, which will give the number of observations to be taken is say 3. Okay, so here this table shows the value of the various ratios. So h minus l divided by h plus l for 0.06.08. so all these are giving the values of the ratio of h minus l divided by h plus l. So if the cycle time is less than 2 minutes, then we had to use the 10 number of samples, and accordingly like say the number of observations, you see, is say 2, 4. So this is how, depending upon the number of sample size we have taken, say sample for 5% accuracy, depending on the sample size that we have taken, we will be getting the different value of the number of observations that need to be taken. Okay, so these are the different values of h minus l divided by h plus l, and depending upon the sample of 5 or 10, we will be getting the different values of the number of observations need to be taken. Okay, now we will see, this is the third method, is the statistical method. A statistical method, according to the statistical method, you see, for 95% confidence level and say for 10% accuracy, the equation comes out to be for the determining the number of observations to be taken, like say n, the number of observations need to be taken for determining the sample size, say so it is 20 square root of n dash is the preliminary number of the sample size, and x sum of the x square minus the sum of the x whole square. So this is how it is determined, divided by the sum of the x. So if we go for so this is what is there in n dash is the preliminary sample size, like sample of 5 or 10 number of observations. Sum of the sum of all x values is the sum of all preliminary set of the individual observations, and this sum of x square is the sum of square of individual observations of the preliminary set of the readings. And so this is the equation which is used for determining the say number of the samples to be taken for 10% accuracy. Okay, and if it is to be reduced to say 2.5% accuracy, then this will be like say simply this 20 will be replaced with the 80. So for greater accuracy or like say greater accuracy or error, like we have said, the 10% error in data or 5% in the 2.5%. so if you want higher accuracy like 2.5%, then it will be 80. The coefficient value is updated to the 80. Okay, now I'll show you according to this example. Let's say for a particular element, let's say 5 preliminary observations were taken. Preliminary observations were taken. Okay, and observations, the value of these observations, like say 7, 6, 7, 7 and 6. It's like the time in maybe minutes, it may be second or any other time value that we can write anything. So the time unit will write here just for a simple set. So here n dash initial number of observations is say here 5. Okay, and then sum of all these individual observations is like 7 plus 6 plus 7 plus 7 plus 6, so it will be say 33. Okay, then sum of all these except the square of all these values, so 49 plus 36 plus 49 plus 49 plus 36, this will give us 219. Okay, now we'll put these values in the equation. So equation goes in like this: for 95% of the confidence level and 10% of the precision or accuracy in the data, here the 20 square root of like 5 into 219 minus 33 square, okay, divided by 33, right, whole square. So this will be giving us the 2.4, which indicates that for 95% confidence level and 10% precision or accuracy in the data, the number of observations to be taken is 3. And if the number of if we want the more precision, then say for 95% confidence level and 2.5% of the accuracy or the error in the data, the value of n will simply be updated 85 into 219 minus 33 square divided by 33 whole square. So this will be giving us the value of 35.828, means 36 number of observations we need to be taken. So if you want more precision for the same confidence level, number of observations to be taken, they will be increased significantly. So here but this method is not considered to be very popular because it is difficult to be understood by the workers especially, and the workers will be those who will be affected by any kind of the time standard related thing. Okay, so this was about the determining the number of observations to be taken for conducting the time study for a given job or for given element. Okay, now we'll see the another aspect that is related with the qualified worker and average worker. Okay, so what is qualified worker, what is average worker? So qualified worker, okay, we try to we know that the different kind of the qualities and abilities and attributes are needed for performing the different jobs. Say, so what we say, like the different jobs require the different kind of the qualities or abilities. So these may be in form of like say the kind of alertness which is needed, the kind of concentration which is needed, the kind of the visual ability to detect the things carefully is needed, the kind of the physical strength which is needed. Okay, then skill which is needed. Many jobs are very skill oriented. The kind of knowledge which is needed for doing the job. So the different jobs require the different abilities and attributes. So the what firms and companies will be doing, they will be hiring the people with the required knowledge and with the required education, and then they are given training so that they can do the job efficiently and effectively. So the hiring so selection is made based on their knowledge and education, and then they are trained or retrained as per the need of the job so that they can do the expected job efficiently. In a firm there can be large number of qualified workers. Okay, so what is the qualified worker and how to understand a qualified worker? Okay, qualified, who is the qualified worker? So anybody or any person who can be accepted as a qualified worker who is having, like say, following things. Any worker who is having the required skill and knowledge, okay, required skill and the knowledge, required physical attributes to do the job, physical attributes to do the job, okay, and the required education and intelligence and education. Okay, so if someone is having these at the same time, so any worker having these things, so that he is able to deliver or do a given job with the standard quality and quantity. So if someone is having these attributes like skill, knowledge, physical attributes, intelligence and education, and he is able to do a given job with the required quality and quantity in terms of the output, okay, then he can be considered as a qualified worker. In a factory there may be very large number of the qualified workers who can do a given job in the required quantity while producing the desired output, okay. But as far as the average worker is concerned, this is just a concept from the statistics point of view. As such, there is no average worker. There can be large number of qualified workers, so it is just an idea or the concept to have the average worker. So how to identify that who can be considered as an average worker, but there may not be any average worker also. So statistically, so average worker kind of term is used just for the statistical purposes, okay. Say for an example, in a company a particular job is being done by 500 qualified workers, okay, qualified workers, 500 qualified workers are doing the job. Then obviously few will be taking the longer time, say 50 or more seconds, and others will be taking lesser time, like say the 40 seconds or less. So depending upon the their abilities, you'll always see that out of those 500 workers, if we'll try to see the distribution of the time being taken by these 500 workers, then we'll be able to clearly see like what is the approximate percentage of the workers who are taking more time or the lesser time than the certain value. Say in this particular case, there are like say 32% of the workers taking they are taking less than these percentage takes the less than 46% of 46 seconds, okay, and say around 34% of the workers take more than sorry, here this is less than. If the distribution of the workers taking the different times for completing the job is seen, then what we get, like say about 32, 34 second is being taken. If you see, about 30 to 34 second is being taken just by 4 workers. Okay, 34 to 38 second is being taken by 16 workers. 38 to 42 second is being taken 38 workers. Okay, 42 to 46 time is being taken by this 104 number of workers. 46 to 50 time. So this is where the tendency of the segregation, maximum number of workers are taking the time ranging from 46 to 50. Then again you'll see greater than 50 to 54, 113, then 54 to 58, 48, 58 to 60 seconds 11, and more than 62 to 66 seconds only 2 workers. So the distribution wise, if you see, the maximum segregation tendency is here. This is where most of the data is segregated, while other side, so this distribution is perfectly normal. That's what we can see here also. So very few percentage are being taken very less time, and very few by very large time is being also taken by very few, and most of the workers take the time in the range of, like, say 46 to 50 seconds. So if we see here, those workers who are taking the time in the range of 46 to 50, these can be considered as average worker. Okay, while these are you can say the slow workers working slowly, and these are the fast workers working quite fast. So these may be considered, who are taking less time, they may be considered to be given incentives. So incentive plans and other things can be given based on this kind of the data. Okay, now how to incorporate and how to consider as far as the effective time and ineffective time is concerned, or productive time is concerned. Say a worker who is working continuously without wasting his time, worker A, okay, and he finishes the job in 60 seconds, 60 minutes, okay, while the worker like say, or indirectly what we can say, worker A is working continuously without wasting time. So what is his output? Okay, and there is another worker also working for 1 hour but involving lot of ineffective time. The white bands can be seen as ineffective time here. Okay, this is the productive time. So if the output of these two is seen, you see, this is the 100% performance, where whatever time is being given, he is doing his job. On the other hand, work done by the worker in 1 hour by the another worker is less. So here we need to say the standard performance. So here this worker B is working slowly, his performance rating will be less, and that's why he will be taking longer time to complete the same job. On the other hand, another worker who is not wasting time and doing the job perfectly, this may be considered as a standard performance. Okay, so now we will talk a little bit about the performance rating. Okay, and the need of the performance rating. So how it is done, what is the purpose of this? Okay, so on this I will be back later. So if we see, basically standard performance, or we can say performance rating. In the time study, what we have seen, we try to obtain the observed time using the stopwatch, and then also at the same time the time study man rates the worker's way of working, whether he is working fast or slow, or some other factors are also being considered when the worker is being rated. So how to do the performance rating, what the rating is, what is the standard performance. So here the performance rating is multiplied to obtain the basic time or normal time, then this is added with the allowances. Okay, so now first the rating, it is rating is like say it is just a method whether the worker is working fast or slow, or it is as per the expectation of the time study man's performance. So there has to be some way out to rate the performance. So the process or means or method of assessing the performance of worker is called, so how we are assessing the performance of worker, that is called rating. Okay, so this process as a whole itself is called the rating, and in the rating evaluates the worker's rate of working with respect to the standard performance concept of time study man. So what the time study man considers as a standard performance, with respect to that the worker's performance is rated. So in the rating evaluates the performance or the evaluates the worker's rate of working considering the standard performance concept of the time study man. Okay, so so what is the standard performance? So because the standard performance is the criteria based on which, or with respect to that, or as compared to which standard performance the workers will be given the different rating. Okay, so the performance rating or standard performance. What is standard performance? Basically it may be the time or the output. Okay, so it is the rate of output or the time being taken. Okay, which rate of output which a qualified worker will deliver, rate of output which a qualified worker will deliver, you see, under certain conditions without over exertion. Okay, then while working in the entire shift or day, whole day. So he has qualified worker has not to overexert, or he has to exert in such a way that he can continuously work in the entire shift with the same pace, in the same way, and he is self-motivated to apply himself to do the job, Okay, so whatever is the time or output being given by a qualified worker without any overexertion or exerting himself in such a way that he can apply himself throughout the shift or the day, and he is motivated enough to apply in the best possible way to complete a job. So whatever that time or that output is rated as 100%. Okay, so basically there is always a comparison. Whenever the worker's performance is rated, the rating is always comparison with the comparison of the worker's performance with the standard performance, with the standard performance. Okay, so it is expected that in the situation when the work is done perfectly by the time study man, so like say standard rating or standard of performance will be given 100% if say someone is walking at 4 km per hour. So those who are walking slowly, they will be rated less, or those who are walking fast, they will be rated high. But this is very subjective unless it is quantified. So with respect to this 100% performance, so someone is being rated, someone is taking longer time to do the job, obviously should be rated low, and someone is taking lesser time to do the same job, should be rated high. So basically the time being taken and the rating being given, product of these two must be a constant if the job is done perfectly. Okay, so for a job, so what we'll say, observed time into the performance rating is basically a constant. Say someone takes the 0.2 minutes to complete a job, is being rated as 100% as per the standard performance. So he is taking, say, so the value is coming 20. So those who are taking lesser time, say 0.16 minutes, so he must be rated 125 performance, and then it will be again constant 20. And someone is taking like say time of 2.25 minutes, so then his performance is slow, he is taking longer time, and he should be rated 80%. So this rating is although subjective, but the product of these two must be constant. Someone is taking less, must be rated high, someone is taking less time, must be rated high, someone is taking more time, must be rated less. So in that case also you will have 20. So this is how the observed time and the rating must be a constant under the best possible situation when assessment is done perfectly by the time study man. Now the factors affecting the rating, factors affecting the rating of workers. Certainly there are a variety of factors, and all those must be kept in mind while assessing the performance of workers. Like as soon as there is any change in quality or characteristics of the material, being processed, the output may be increased or may decrease. So this also has to be, even the minor variation in the material properties which is within the limits. So on the higher and lower limit cases with the material characteristics, there can be a change in the performance or change in output which is being given by a worker. Similarly, there can be variation in performance of the systems which are used, variation in efficiency of the system, like machines or tools which are being used, that can also bring in change in the rating or change in the output. Okay, then there are many jobs which needs lot of attention and alertness. So with that time there will, due to the fatigue or due to the other reasons, the variation in mental alertness can also affect the output. Then minor variation in the methodology or the way by which the worker is applying himself during the job, or the working conditions are getting modified or altered, so that can also affect the output. And lastly, the climatic conditions, like in India also, like we have temperature variation from 45 to the almost 0 degree. So the climatic conditions affect the way by which the workers can apply during the work. Too harsh conditions on the either side adversely affect the performance. For example, very low temperature conditions reduces the activity and the sensation and the ability of the body parts also to apply during the job. So the climatic conditions, lighting, humidity, temperature, etc., all these affect the workers performance, so that will be affecting the rating as well. Okay, so this is about the rating standard performance, or the observed time and the performance rating relationship and the factors that affect the rating. Now we'll talk about the different methods which are used for the rating purpose. So there are four common methods which are used for the rating purpose, like the performance rating is based on the performance of the operator under the observation, and this is compared with respect to the normal performance. Okay, there are four methods which are used for the rating the performance depending upon the kind of job. The different methods are used. So pace rating, in brief I will tell. The pace rating is about the way by which worker applies himself during the job, how fast he is doing the job. That is the criteria. That is why it is also called a speed rating. Okay, how fast the worker is applying himself. Then Westinghouse rating system considers the lot of other factors, like how difficult the job is. Okay, what is the consistency in performance of the job, what is the degree of efforts which are needed, okay, and how fast the job is being done. So it considers the four different factors. Objective rating is a combination of the speed and the difficulty level related with the job. So both are rated, the speed at which the worker is applying during the job and what is the degree of difficulty related with the job. And the synthetic rating is about like the normal observed time and the time obtained from the PMTS method. These two are used to calculate the synthetic rating. Okay, so pace rating about the speed. A Westinghouse rating system is a combination of the different four factors. Objective rating is about the speed and the degree of difficulty associated with the job, and the synthetic rating is about the actual observed time and the data obtained from the PMTS data bank, that is a predetermined motion. So like the time required for the job is obtained from the handbook, and that is compared with the actual time being taken observed through the stopwatch or time watch time study method. Okay, so so these are the four different methods. In brief, I will talk about all these four methods. Like say, so the pace rating or the speed rating is based on, it's a judgmental method, judgment based on the operator's speed of movement, how fast he is applying himself during the work, and that is used to rate him with respect to the standard performance rating, whether he is applying fast or slowly. So that is the sole criteria for the rating purpose. In the Westinghouse rating systems, it considers, it is more comprehensive. It considers the skill needed for doing the job, efforts needed for doing the job, and the working conditions in which the job is done, and then consistency in performing the job. It's a more comprehensive, and it considers the different aspects related with the job for evaluating the performance of worker. So like skill rating is given like is a super skill requirement, or like skill of the worker is super skill, or the poorly skilled. Okay, so based on that, different ratings are given, including from very poor to the minus 22, minus 0.22 to plus 115. So the studyman will be observing the worker and analyzing and then giving the ratings if he is poor, fair, average, good, excellent, and again there are the different grading. So each of the category has the two different grades, and then values are assigned for each of the categories. Okay, so worker will be evaluating the time studyman will be evaluating the worker with regard to skill and will be assigning the different values. Then effort rating is also done in the same way. The how much effort is being given or delivered by the worker in performance of the job, so that is rated poor, fair, average, good, excellent or excessive, and accordingly the different values are assigned. Okay, then condition rating, the conditions under which the job is to be performed. So the conditions poor, fair, average, good, excellent or ideal, and then accordingly the ratings are given. And here consistency, the perfect, excellent, again that is rated and we assign the different numerical value. Then sum of these skill plus effort plus condition plus consistency, algebraic sum of the numerical values I obtained by the worker is used to determine the performance rating of the worker. So by algebraically combining the ratings with respect to each of these four factors, the final performance rating is estimated. Okay, then objective rating, as I said, it combines the two aspects. One is the pace rating or the speed rating, and another is the degree of difficulty associated with the job, and these two are clubbed together. So pace rating, about the pace rating I have already talked. The rating of the job difficulty is done by selecting the different the factors that need adjustment factors that are needed with respect to the job performance. What are the different things that are needed while performing the job? So when the worker is performing the job, it is analyzed to see the degree of difficulty associated in the performance of the job, and then it is clubbed with the pace rating. So these are the different factors which are applied, which are considered for determining the degree of difficulty associated with the job. So pace rating is one thing and the degree of difficulty is another. So what is the amount of body used for performing the job? If the foot pedals are used, use of bimanualness, or the kind of the hand and eye coordination needed for performing the job, any handling requirement during the work, or the weight is also considered if the job is to be done is light in weight as far as the handling of the job, like the light very the low weight the sample, or high weight the tools are to be used, so that will be putting a lot of fatigue or the resistance in performance of the job. So for these different factors, these two Mundell and the Denner, they gave the tables for giving the adjustment factors, so that the various difficulties in operations being performed can be identified. Okay, once those degree of difficulties numerical values for related to the degree of difficulties are identified, and then pace rating is used to determine the objective rating. So objective rating combines the pace rating and the degree of difficulty associated with the job. This is more advanced in nature. It considers the various other factors associated with the how much difficulties are involved in performing a job, depending upon the weight, complexity, the body use, etc. as I said in the previous slide here. So depending upon these factors, the different the degree of difficulty is identified, and that is used with the pace rating to find out the objective rating. Okay, synthetic rating is, this is more simpler method. In this method has a very two advantages. There is no subjectivity as such, just the time being taken by the worker is quantified by this time study when, and there is no subjective rating. So time study man is not supposed to rate the workers performance subjectively. Okay, and that is why it is more consistent. So there is no subjective rating by the worker, or subjective rating of the worker by the time study man, and it is, therefore it is more consistent. So time study is made as usual, and for manually controlled elements, obviously the work cycles are, a few work cycles are manually controlled elements are selected for determining the synthetic rating, because those machine elements which are performed automatically by the machines, the synthetic rating is not obtained for that, because obviously they are always rated as 100%. So manually controlled elements are selected for the rating purpose, and then using the predetermined motion time database, the time for selected element is identified, and then using the PTS, predetermined time data, and observed time from the time study, this ratio is used for the rating purpose. So synthetic rating is obtained from the ratio of time being taken to perform the job as per the PMTS, okay, and the time actually being taken in performing the job by the worker. So the performance rating by the synthetic rating method is obtained from the ratio of time being taken using the PMTS method and the actual time being taken, observed time obtained from the time study method. So this observed time and the time from the PMTS method is used to quantify, or we use to determine the synthetic rating. Say here is an example only. Say these are the different elements, 8 elements, 1 2 3 4 5 6 7 8. Okay, and type of the element, like element number 3 is the powered element, right? Means it is being performed by the machine. Rest of 7 elements are the manual elements. So say if out of these 7 manual elements, if we select element number, different elements may involve different degree of difficulties, different ratings they may give. So what we do, we select say 3 elements like this, 2 5 and 8. Okay, and the PMTS time value for these, this is the actual time being taken by the worker according to the time study for these 3. Okay, and then the time for performing the same activity obtained from the PMTS system, that is the database system, and that time value is obtained, and then the ratio of these two will give us the ratio of these two will give us like 0.45 divided by 0.16. So this will give us the 95%. This is always 100% power, the one. And similarly 0.25 divided by 255 divided by 0.26, this will give us 95%, and similarly this one. So what it is giving us, the 95% rating. Now the same can be used, average performance rating. So if we have got the performance rating of the workers for 3 element is 95%, then this rating can be used to multiply with the other elements also. So here, like say performance rating is multiplied here, 95%, performance rating of 95% multiplied here, and similarly in these two cases as well. So synthetic rating is being obtained just for these three elements, number 2, 5 and 8. That is obtained say 90%, 95%, and this 95% rating is then multiplied with the other manual elements to determine the normal time for remaining other four elements. So that's how we determine the rating here is say 95%, and then we simply multiply it with the 95%. So here we just overlook, we don't consider this in arriving at the standard time. In that case, using the synthetic method, normal time plus normal time multiplied by the rating plus the machine time or the machine element time. Okay, this is how we will be getting the standard time. So in this case, allowances are not added to the machine elements, these are added to the manual elements only. So that's how we'll complete this lecture. So here I have talked today about the methods which are used for determining the number of observations, for conducting the time study with the desired degree of confidence level and the accuracy. And we have seen that there are three common methods. One is Mundell method, a standard table, the customized table approach, and then statistical method. Thereafter we talked about the qualified workers, then the performance rating and how the performance ratings are given, and then what are the different methods which are used to rate the performance, like the pace rating or speed rating, Westinghouse rating, then objective rating and synthetic rating. Okay, so we'll take up the other things related to the time study in the next lecture. Thank you.